Hello everyone, thanks for tuning in. I'm your host Edwin Braun and I will present this quick start tutorial to get you started with your latest release of Thinking Particles. As you might know, we just released Thinking Particles 7.3 Service Pack 4. One would think this is just the fourth incarnation of our Thinking Particles with minor bug fixes and such. Nope, it is not. In fact, Service Pack 4 is a complete new version of Thinking Particles, including some major new nodes and especially some more speed improvements. A lot of internal housekeeping to our code base has been done. Thinking Particles now uses the latest compilers and frameworks available, including OpenVDB version 11, a large improvement over version 9, which we used before. So depending on how much you do with the volumetric effects in 3ds Max, you can expect some great improvements there. But as mentioned before, this is not all. We have explosions galore. Before we start, let me explain what we are going to do in this tutorial. First, I will show you an explosion system scene that ships with our release of Thinking Particles. I will explain how this scene was set up and how it works. This should get you started and prepared for what our explosion tool does and how it is used. After I explain the simple scene to you, I will do a from-scratch setup, beginning with a fresh scene, explaining how to get the explosion tool set up and working for your own shots. Keep in mind there will be more videos following explaining more of the new features. Anyhow, let's dive right in. So let's just start with loading the sample scene I was talking about. So we're just going to our file open, and when Thinking Particles was installed, we automatically installed a lot of Thinking Particles sample scenes for you to explore. And those sample scenes, there are really a treasure trove. You can find a lot of answers just by loading the scenes or even use those as your base to start off. So as I mentioned, we ship with a lot of sample scenes. So let me just show you here. When we click in the properties, there you can see the folder where it's by default installed. That's your username, document 3ds Max version scenes. That's the folder. And it ships with 433 files, sample files. So let's just go and load the latest samples we have. That's the Service Pack 4 version, and I already prepared the Ricochet tutorial, and I'll load this scene in. So now, how do we access Thinking Particles? We just click our helper object, or if we wanted to, we can just go here and select Thinking Particles here. It doesn't matter, whatever you prefer. And we also have a shortcut to bring up the properties window as well. So however you prefer, you can start and bring up your Thinking Particle system. So let me just close this here and we'll start here. So I guess before we start analyzing the scene, and I'll explain you how our new explosion system works, we'll have a look what this scene does. So this scene shoots bullets from our rifle. By the way, I modeled this amazing rifle. And we shoot a bullet and it bounces around here. And that's a metal car, a crashed car, as you obviously can see. And that's our brick wall where the bullet bounces off. And for each bounce, we create some debris, some dust, and all kinds of effects. So I'm going to abuse our explosion system for bullet shots now, which is totally fine, I guess, because no one knows. But it just shows how flexible and how great or good our explosion system is. Let's go back to the scene. So how did we do this setup? Because there's some advanced stuff going on I want to show you. It might look scary to see all these wires and stuff here, but it's really not that complicated. And I'll explain how this setup works. So the first thing we're doing is using our object box 3, and let's see what is our object box 3. And there we see a little bit of a naming convention would have been nice. So that's our gun. Let me just fix that. So that's our gun. So and we can see it updated here. So we use matter waves to emit a particle, a bullet from our gun. And I want to emit it obviously from the barrel of our gun. So I selected this face here and assigned either a material ID or we use a selection. Let's have a look. So in the emitter section, we can define how we want to emit the particles. And right now I just use the selected face. And I will just emit one particle from the selected surface of our gun here. Our amazing model of a real gun. So that's actually what's happening. We emit a particle here. And when we shoot our particle, we can see we create this particle here and we create another particle exactly at the position where the particle was emitted. And here, down here, we can see there's a bullet flying to its next bouncing point, flying here. It's pretty fast. And now we get the ricochet here and these little dust explosions and debris and stuff, whatever we want to simulate. Back to our setup. So that creates our bullet, and we give our bullet an initial speed. We can see that here, a speed of 1,000 meters. So that's kind of in a realistic speed for a rifle bullet. And the next thing we're doing here, at the same time, when we create here our bullet with the gun object, we create at the same position where we born the bullet, we create another particle that just stands still with zero velocity. So at the same position, we create a particle to indicate where the bullet left our barrel. And we put this particle in the initial positions. And that's the important part with our explosion system. Our explosion system works based on whatever we throw into the initial positions group. That will be taken as our center of the explosion. The rest is all basic thinking particle stuff. So we get here, we take the position, the velocity of our bullet. We get the direction and we align our particle along the way of travel. So that's a pretty simple, straightforward setup. And this position as well, the particle for our initial position, is stored in a memory operator. And now don't freak out, there's a lot of stuff there. And this thing, you don't have to be scared about this amount of variables we have there. That's all done for you. It's automatic. And I'll show you later when we do our from scratch scene setup. But all this stuff is already there waiting for you to be used. So what does that mean? So our initial position from this particle alone. So we shoot one bullet and we create this initial position for our little explosion or ricochet effect. And then we store this particle, and along with this particle, we store an impulse value. That's our impulse value. We just calculate the impulse value from the velocity, and we multiply it by 0.5. So we use half of the impulse. So half of the speed of the bullet is transferred to our particle position. Then we set up our spike count. We want to have a lot of spike explosions. We set up the lifespan, the opening angle, all the settings we have, and we set up the shock ring, sand count, and all these particles we want to use for our barrel explosion, or when the bullet leaves the barrel. All the settings we want to apply to our position here, our initial position particle, where we want to have the barrel explosion, or where we want to have any initial position at all. So now Keep in mind, this is only for the first bullet we create, not for the ricochet. Let's move on to our next dynamic set. So this dynamic set is creating our bullet and creating the initial position. The next thing we have here is our new deflector system. Our new deflector system is unique because it is fast, multi-threaded, and allows you to have multiple collision objects. So we can now handle with our deflector system multiple objects. So we can collide between all these objects, floor, this car and wall object. And then our deflector has the usual settings, parameters we want to have or expose or adjust. And the same for our spikes, which are the spike explosions. When we have a bouncing or ricochet effect, we can also control how they bounce. And that's practically all. And one more time, we have our deflector particle data. Also, this is generated for you. You don't have to think about it or use it. If you want to use it, it's fine. But if you don't want to use it, it's also fine. Doesn't matter. But everything is prepared for you with our explosion system. So right now, what we have here, inputs. So we want to store our deflection vector, so our bounce off vector, and we want to store the power of impact at that point. So we store that in memory. So now we know for a spike bounce how fast it was and how much energy it had. And the same we do for our main particles, for our bullet. We do the same. We store the deflector and impact. And here we go, and let's have a look at the explosion system or dynamics that we have here. We have this top part and we have this explosion tool. And I will explain how to create that. Don't be scared. You don't have to wire this. It's already wired for you. As I mentioned, the only thing you need to feed in is a collision plane maybe and an initial position. The rest is just fun setting up your explosion in the way you want it. But let's start at the top. And when I say at the top, as usual in Thinking Particles, hierarchy is important, it's crucial, and it's also the most powerful tool you have at hand. Because the hierarchy allows you to play God and decide which operator is evaluated first, second, third, and so on. So keep in mind, hierarchy is not an annoyance or something that is there to bother you. No, it's the opposite. It's the full power of Thinking Particles. The hierarchy gives you all the power you need. And yes, you can abuse it. Yes, you can confuse it and create a lot of havoc by not respecting the order of things. But once you get it, it's really the most powerful part of Thinking Particles. So saying that, here on top, visually on top, it doesn't matter where we put our nodes, but visually on top, we also have our initial positions as the first entry, because we want to first start with our initial positions before we have our explosion effect working with the initial position. So what did we do here? So what we do here is when a particle is born, so an initial position, that may be our bullet exit out of the barrel, the position at the barrel end of our gun, or the positions where ricochet effects happens. So it doesn't matter. Whenever an initial position is born, we do some things. And probably what we do is we memorize some effects or transfer some stuff or create some other things. What we do here is we use the P data from our deflector, where we get the particle, the initial position of the particle, and then we grab our deflect vector and we can see where we have the deflect impact power. So that's what we do here. Let me just move that a little bit down here so that we can see much better how this is wired up. So what we have is the deflector, direction. So that's the burst direction we want. And the same for the spike direction. So we get from our memory the correct bounce vector, so to say, or bounce off vector. And then we just set a burst variation. I'll discuss in a later video how the explosion tool works, what settings we have there. But it's just a value we feed in here. The spike impulse, same deal. It's a multiply. We get the impulse and we reduce it again by 50%. So that's all we do here. Now let's go on to our explosion tool here. As mentioned, you don't have to set up. That's all done for you. We have multiple aspects happening here. We have some bursts happening where we control the bursts. We can control them just by, like any other node, you have parameters and you can adjust them, or you can feed in values as well. So it's a normal standard node like any other Thinking Particles node. But the great thing is, this is already the whole system. This is why we call it systems. This whole system is set up for you. So the only thing you usually want to care about is the global scale, global speed, and then the individual nodes, the individual effects you want to have. Also, the whole system is taking care about gravity-based effects in the context of explosions. So keep that in mind. All the explosion particles have their own gravity, turbulence, and friction. And all this is based on physically accurate calculations. So friction happens based on speed, weight, and all these kind of parameters. And adjust your explosion to your liking. We have some curves here. The expansion curve I will talk about in another tutorial video, how our explosion tool works, what we can do with that. But you have real good control. The same with the mass curve. And we can define standard shapes for our debris, our sand, particles, and all kinds of adjustments. So let's have a last look at what's going on here in our scene. And that's actually it. Let me just go through here. We emit our bullet. You can see here's the bullet flying and ricocheting off, hitting the wall with this angle and flying off. And we have some turbulence in there. We also have some chaos in the surface to simulate a rough surface or a flat surface, all these kinds of effects. So that's the scene. How about we create our own explosion scene? So just that you know what I was talking about, that you only have to feed in the initial positions. Let me reset the scene. So I'll reset the scene. And we start from scratch. So the first thing you usually do with Thinking Particles is you go into the particle system and create your Thinking Particle system inside of 3D Studio Max. Then we go to Modify, bring up our user interface, and then there's many options to start. I usually suggest explore one of the 433 samples and pick the one that is closest to the project or things you want to do and go from there. It's always a good start. However, we can start from scratch. Let me just show you. Let me create one particle group. Let's say meteors, or whatever we want. So let's say we have the meteors here. The next thing we want to create is a few dynamic sets, and I usually like to have one create dynamic set, another dynamic set I usually name simulation, and then we can have something else, debug, or whatever comes to mind. I don't care right now. So first dynamic set is we want to create some particles, right? So I think the first thing always we want to define is the position. So for that, I would just use a helper object, a point helper. Just put a point helper up here. Let me just move the point helper here down, and we have a point helper. The next thing I want to do is I just right click into my sheet here, and we have operators, generators. So we want to generate something, and I'll just use our position born operator. So all the position born wants is a position. We could type in the position or feed in another operator, but I will use a node operator. And by the way, to bring up this search for nodes, I just press the tabulator key, and then I'll type in node. And now I'm able to pick a node and feed in the position. That's all what we want. So I'll feed in the position of our helper node, of our point node. So we have the point helper feeding in the position, and the next thing we want to do is maybe give it a little bit of more power here. And let's see what's happening. Okay, we spray up in the sky. I don't want that. Let me just make sure we turn off real time, because for simulations, that's very important that we do that. Let me increase the lifetime maybe to 100 or whatever we want to have here, and make sure that we're pointing down. So right now the direction has a variation, which is fine, but we are having Z up, so I want Z down. Let's go here, and we're spraying down. Maybe we are generous and give it more frames, and we can see that. Maybe this is way too fast. Let me just see. That's too slow. I don't like that. Let's go here and see how that works. Yeah, that looks good. So we have the particles streaming down. The next thing I want to do is probably have some impact-based effects. So I'll create a floor. Let me put a floor here and turn on the grid, and there we go. So now I want to have, when we go back to our thinking part, let me just make sure you can follow here. So when we go back to our thinking particles, we have now, I think, everything we need here. We have position born, everything is there. So now for the simulation part, we're going to use our new systems. And the systems can be found in, as I mentioned, systems, black boxes systems. So they're ready-made, already wired for you. So I'll just get the deflector. And the deflector system takes care about deflecting or bouncing off particles. So we are going to do that. And the great thing is, in contrast to our universal deflector node, the new deflector system allows you to pick multiple objects. Right now, I only need to pick the box down here, but I can pick multiple objects. So I picked now the objects, and as I mentioned, we already have prepared for our explosion tool to store the deflector data in here, the vector of bounce and the impact energy. So, and we can also, let me just reduce the chaos a little bit, we can already see we need to change our group, the meteors, and that reminds me, let me just go back here. We want to born our positions in the meteors. So now all the new particles will be born in the meteors group, and our deflector is using the meteors group, and it automatically creates intersection points. So wherever the impact happens, let me just go to a 2 millimeters distance. So wherever an impact happens, it will born a particle with a lifespan. Let me just get the lifespan to 20 maybe. And we can see it's going into the deflector intersect group. So how can we better see if that what we're doing is working? So we can say, I don't want the global settings. I want to have flakes, and maybe we want to change our color as well. So let's get some color here. And now in the master dynamic set, I'll say don't force this setting for all my particles. And that means now if we play back, we should see our particles here, our little flakes that are created. And if we wanted to have them with a different size, we could do that with particle size and so on, but that's not the point. Let me just go back to force the setting so that all particles have the same visualization. So now, how about we rename that from debug to explosion? And as I mentioned, what we have now, automatically, this deflector system is creating our initial impact points. So now I know there was an impact, and so on. So the next thing we want to do is, with our explosion tool, just go to Black Boxes, Systems, Explosion. Now I click the explosion tool. Now look what happened. It filled up a whole lot of particle groups, crazy amount of particle groups. All the settings, all the stuff is done for you. And it's so simple now. All we need to do is, because our explosion system, the only thing it wants is initial positions. That's the only thing it wants. And we know our deflector does it in the deflector intersect. So what we are going to do is now our initial positions, so that's the impact points, has to go in the initial position. And that's all I need to do. Now, what we have is already something that's already kind of working. So let me just make sure we don't overdo it, because we would end up with a lot of explosions. Let me just go with 2 particles per second so that we can see what's going on. And here we go. We have our explosions happening beautifully. So right now, by default, everything is on. We have geometry set up. We have particles, condensation, shock waves, spikes with trails. Everything is set up here. And now the great thing we have here is we can turn off, for example, the debris. We can turn off, for example, the sand. We don't want that. We don't want spike sand, and the condensation, we also don't want that. So now I turned off these effects, and now let's have a look how this thing looks like right now. And on each impact, we get our shock wave, we get our little burst, and a little explosion. So let me just zoom in a little bit more. So these are the default settings, and we can adjust them in any way we want, because every single effect has its own settings, and we can adjust the amount of particles, impulse, effect, and so on. However, we already prepared for a global scale and global speed. So let me just increase the global scale to 2000. And that means everything is now multiplied and we get a much bigger explosion. And let's try 6000 just to show you the kind of effect. So now we have much more violent and bigger explosions here. And keep in mind, you still have individual control of each single explosion. So this is how you can adjust this. And when we have one more last thing you should do is, here's our box or our plane, and we can see we have particles that are penetrating underneath our collision phase. Because we are doing ground explosions or explosions of solid objects, we can define here, it's already set up for you. You just pick your plane or object, and then it will automatically remove all particles that would go inside of a volume. And now we have a clean surface explosion where only the particles, the burst and stuff is going outward and not inside of an object. So it's that simple. So that's it about how to create the explosion tool. And it is really that simple. You saw that. You create your particles, you create your initial positions, you tell or you feed from outside in this particle group the initial positions, and from that point it will create explosions. And you can adjust a lot of parameters, and this is for the next tutorial to come. I hope you enjoyed this tutorial. Look out for the other tutorials that will be coming soon, and have fun exploring the new features in Thinking Particles Service Pack 4. Thank you so much for watching it. Goodbye.